Hey guys, this is JP1 from Plain Exceeds Tutoring. In this video, we will be talking about how to solve systems of linear equations, which are sometimes referred to as simultaneous linear equations. Don't forget to use my referral code JP120 to receive 10% off on your next tutoring package. So when we solve a system of linear equation, we're trying to find the coordinates of an intersection between the linear equations in the set. So let's say we have two linear equations. We would be trying to find, say you have a linear equation number 1 and a linear equation number 2. We would be trying, the solution to this set would be this coordinate right here, where both equations have a solution. And we can solve for any number of variables as long as such an amount of linear equations is given. So if we're trying to find 3 variables, for example, we need 3 linear equations. If we're trying to find exactly 2 variables, we would only need 2 linear equations. But for this video, we are only trying to find the values of 2 variables when given 2 linear equations. In all the examples that I'm about to show you, there will be exactly 1 solution, but also be aware that at times you can have a system of linear equations with no solutions or even an infinite number of solutions. So for the former, or for no solutions, the 2 linear equations that you're trying to work around with, they just need to be parallel with one another. So remember, parallel, which the sign for parallel would just be two L-like shapes. For it, all you need is for the 2 slopes to be the same. So the m is going to be the same for both of them, but the y-intercept is going to be different. And this would get you no solutions, and that would be the symbol for no solutions. If you have, on the other hand, if the y-intercept was the same, and the slope was the same as well, in that case, you would be getting the same exact equation for both of them, and as a result, you would have an infinite number of solutions. So in this one, you would have both m and the y-intercept same in both equations. So there are a number of ways to solve a system of equations, but we're only going to be focusing on the most common two methods, which are substitution and elimination. So in the substitution method, we would be utilizing one of the equations from the system to solve for one variable in terms of the other, and you just plug in this expression in the other equation, substituting for the variable. In the elimination method, on the other hand, we would be multiplying one or both equations by constants, so that we would be able to add the 2 equations to eliminate a variable. And from there, we would be trying to solve it in terms of the other variable. So now let's just try working on a couple of examples. Right. So on the left and right, you're probably going to notice that these are the same exact equations. We're just going to be doing substitution on the left and elimination on the right. So for this first example, we have 3x minus 2y equals 7 and negative 2x plus 3y equals negative 3. If we are substituting, all that means is that we're just trying to make sure that one of these variables is written in terms of the other. So let's say we use the first equation. We could rewrite this equation so that it's it's y in terms of x. We're trying to solve for y in terms of x. So in this case, you would have y is equal to some mx plus b. We're trying to get to this form. So in order to get here, we have 3x minus 2y equals 7. So if we subtract out the 3x, and then we would get negative 2y equals 7 minus 3x. And then if you divide by negative 2, you would be left with 7 over negative 2 minus 3 over negative 2x is equal to y, which just simplifies down to y is equal to negative 7 over 2 plus 3/2 x. So now we can use this equation right here we can use this expression 7/2 plus 3/2 x plug it into the y equation, or plug it in terms of for y instead for the second equation. So for the second equation right here, and so we would be getting negative 2x plus 3 times y, which is negative 7/2 plus 3/2 x, which is equal to negative 3. And now we're just trying to solve this, which is through algebra. You would have, you would have negative 2x combining like terms, or first distributing. We would get negative 21 over 2 plus 9 over 2x, which is equal to negative 3. Now, if we combine these like terms, we would be getting that's equal to negative 4 over 2x. So this is just equal to 5 over 2x plus, or actually rather, minus 21 over 2, which is equal to negative 3. And now to solve this, problem, we just need to add 21 over 2 on both sides. Cancels that out. 21 over 2 on both sides. And so we'd be left with 5 over 2 x is equal to negative 3 plus 21 over 2. Negative 3 can also be written as negative 6 over 2. So negative 6 over 2 plus 21 is just 15 over 2. And just with this now, we can simplify this out. So if you divide by 5/2, so to divide by 5/2, that's like saying you're multiplying by 2/5. So you multiply by 2/5 on both sides, and you would be getting the 2's cancel out, and you get x is equal to 3. And x value is equal to 3. And now all we need to do is just plug in the x value that we just got into the substituted form for y, which is once again negative 7/2 x plus 3/2 x, or negative 7/2 plus 3/2 x. So this would just be negative 7/2 plus 3/2, and the value for x that we just got, which is 3, is equal to y. And when we do this, our solution would be, if we multiplied 3/2 with the 3, we would get 9/2. And if we subtract out, or if we add a negative 7 over 2, 9 plus a negative 7 over 2, or negative 7 over 2 plus 9 over 2, is just equal to 2 over 2, which is equal to 1, which would equal y. But now we have our value for x and our value for y. So our final solution would just be x is 3 and y is 1. Now let's try solving the same exact problem using elimination instead of substitution. So in elimination, what we're trying to do is we're just trying to multiply either of these, we might need to do both of these equations by some constant, so that when we add them together, we would get 0 times one variable plus some value times the other variable. So if we multiply both of these equations by, let's say, if we multiply the bottom by 3 and the top by, let's say, 2, we would be getting 6x minus 4y is equal to 14. And on the bottom, we would be getting negative 6x plus 9y is equal to negative 9. Now, if we add these equations together, and we can do this because on the bottom, we would be, on the left side, we would just be adding 6x minus 4, 6x plus 4, 6x minus 4y, we would just be adding negative 6x plus 9y. And on the right side, we would be adding negative 9 to 14. And we already know that they're both equal to each other, so there shouldn't be any changes to the problem itself. So if we add this together, 6x minus or plus a negative 6x, that's equal to 0x. Negative 4x plus a positive 9y, or negative 4y plus a positive 9y would get you a positive 5y, and this would equal 14 plus a negative 9. Well, 14 plus a negative 9 is just the same thing as saying 14 minus 9, which is equal to 5. And with that, you can ignore the value for x, since 0 times any value is just going to be 0, and divide by 5, and you get y is equal to 1. And now that you already have a value for one of these, since you already have the value for y, you can plug this y value in to either of those equations to begin with. So let's plug it into the second equation. Negative 2x plus 3 times 1 is equal to negative 3. If I add 3, rather subtract 3 to cancel this out, and subtract 3 on both sides, I would be getting negative 2x is equal to negative 6, divide by negative 2, divide by negative 2, and I get x is equal to positive 3, which is the right solution. So once again, we get 3, 1 is our final solution. All right, now let's try this word problem about systems of linear equations, which comes from the SAT practice test that you can find on College Board. This is from the calculator section, and it's question number 19. And let's just use the substitution method for this one. So it states that a food truck sells salads for $6.50 each and drinks for $2 each. The total revenue from selling a total of 209 salads and drinks in one day was $836.50. And we're trying to figure out how many salads were sold that day. So first, let's always make sure that we have appropriate variables written down for each thing. So let S be the number of salads sold. And let D be the number of drinks sold. So we know that in total, the food truck sold S plus D, which would be the total number of salads and drinks together, is going to equal 209. And we also know that the price for each salad is $6.50 times S plus $2 for each drink, 2.00 times D. And this got the food truck a total of 836.50. Now, if we try to just if we just try and substitute right here, we can either substitute in for S or for D. Since we are trying to solve for the number of salads, it's best if we move the D on the, if we move the S on the other side and set it so that it's equal to D. And this way, what we're going to notice is that we would be first solving for S, and that's what we're trying to find either way. So in this case, we would get D is equal to 209 minus S. And if you plug that in for this D value right here, we would get 6.50 S plus 2.00 times 209 minus S is equal to 836.5. Well, this is also, if we distribute the 2 to the 209 and the S, we would get 2 times 209, which is 418. 418 minus 2 times S, which is just 2S. And you have a 6.5S, 6.50S on the left side, 2.00S on the right, is equal to 836.5. And so now, if we just combine these like terms, the S's together, we would get 4.50S plus, and if we combine the 418 with the 836.5, well, that just means we're subtracting 418 from the 836.5, which gets us exactly 418.5 is equal to 4.5S. And now if we just divide by 4.5, we get S is equal to 93. So in total, on that day, on this particular day, there were 93 salads sold. Now in this next problem, this word problem, let's try to only use elimination instead. So in this one, we have that the score on a trivia game is obtained by subtracting the number of incorrect answers. Let's say that the number of incorrect answers is W. And let's say number of correct answers is C. If a player answered 40 questions and obtained a score of 50, how many questions did the player answer correctly? Well, if there are 40 questions in total, that means the number of correct answers that he had plus the number of wrong answers in total would add up to being 40. That would be C plus W is equal to 40. And the score that the person gets is equal to 50. And we know that the score is obtained by subtracting the number of incorrect answers from twice the number of correct answers. So we have 2C minus W to be equal to 50. Now, if we're just trying to eliminate this, we can eliminate the W's out immediately without multiplying by anything, without multiplying by any constants, if we just add them together, if we add up these equations together. And this gets us 3C is equal to, so that's C plus 2C, which is equal to 3C, and 40 plus 50, which is equal to 90. And so if we divide by 3, we get C is equal to 30. And this means that the player answered exactly 30 questions correctly. Thank you all for watching, and I hope you guys learned something new today.